Hi everyone, this is the section for 12.3. Before we jump into our statistics today, I want to review systems of equations and solving it graphically. That way we review both solving systems and graphing at the same time. This was a question that was commonly missed on the exam, so don't make the same mistake twice. Review this and get it right on the final. The first thing we have are two equations, x plus 3y equals 5, 3x minus 3y equals 3. So I'm going to just take a moment and rewrite these into y equals mx plus b. That way I can see the slope and I can see the y-intercept. So for this first one, x plus 3y equals 5, I will move the x to the other side. So I have 3y equals negative x plus 5. Then we have to divide by 3. So we have y equals negative 1/3 x plus 5/3. So that's our first one. And then for our second one, we'll have 3x minus 3y equal 3. I will move the 3x over. Negative 3y equals negative 3x plus 3. Divide by negative 3. We have y equals x minus 1. All right, so now I have my two equations. We can start graphing now. I'm going to try to find some sort of middle here. Okay. Here we go. And the first one we'll plot is x minus 1. So that tells us our y-intercept is at negative 1. And from there we have a slope of 1. So positive goes up 1 over 1. Up 1 over 1. Now my technique is plot 3 points and then connect the dots. So from here, it'll go something like this. And this is, we'll label it x minus 1. Okay, our second one, negative 1/3 x plus 5/3. So 5/3 is 1 2/3. So 1 2/3. Probably right there. And then we're going to go down. We have a negative slope, 1 over 3. So we go down 1 over 3. Okay, and then we'll go down 1 over 3. Something like that. Now, graphing this one, it's a little bit challenging. And I got off a little. Something like that. Okay, so from here, I'll label this one negative 1/3 x plus 5/3. Okay, so now I know which line's which, and I can tell that we have an intersection right there. That's our solution. So we can see that x is at 2, y is at 1. And so we will double check that this solves our system. So x plus 3y equals 5. If x is 2 and y is 1. Okay, that one checks. Next we have 3x minus 3y equal 3. X is 2 and y is 1. And that one checks. So our solution is 2, 1. And we solved it graphically. Now please note, all of the work that I just did on the side of the graph, that's what I expect to see on your exam. So when I say show your work, I don't mean magic a graph out of thin air and random solution. No, I mean I want to see all your calculations. That way I can follow along with you, especially if you make a mistake. I can find exactly where it is. Like, for example, let's say you made a mistake right here. Then I could be like, ooh, okay, you were really close, but you're gonna lose a point right there. Instead of, oh wow, I don't know where you made your mistake because all you gave me was a random answer with no work. So the whole thing is wrong. You get 0 points because I cannot find your mistake and you gave me a random wrong answer. So please show the work. Show all of this stuff and all of this stuff and then this stuff so that you can get your credit, okay? It helps the math teacher understand where you're making mistakes or where you're not making mistakes. I can see all of your work is great and you know what you're talking about. So yes, the test is showing you learned it and you know it and you understand it. Congratulations. Okay, either way, whether it's for your benefit or to show a mistake, you need to show your work. All right, now let's talk about statistics. This is 12.3. We're going to talk about something called a measure of central tendency. So we'll look at the mean, median, mode, and mid-range, and then calculate measures of position such as percentiles and quartiles. Okay, so the first thing is, let's know what we're talking about. An average, something we've heard of and used before, is a number that represents the data. So when I say the word average, I could be talking about the mean, I could be talking about the median, I could be talking about the mode, I could be talking about mid-range. Each of these will result in a number that is near the center of the data, which is why averages are called the measures of central tendency, right? Because it's near the center. The arithmetic mean is symbolized by, where's my pencil? The symbol x bar, or by the Greek letter mu. So either time, anytime you see these things, we will think of the arithmetic mean. And what I mean by that is that it's the mean that you learned in middle school, where we add all the pieces of data together and divide by how many there are. This is that symbol, right? The X bar. And then here we have another symbol, the summation. So the sum. Remember, we're adding them all up. So the sum of all the data over how many there are. All right, so let's do it. Let's determine a mean. Our first example, determine the mean of the group of firefighters. All of their ages are listed here. We want the mean age. So we have X bar is the sum of the data over how many there were. So we have 30 plus 21 plus 51 plus 37 plus 51 over, how many are there? 1, 2, 3, 4, 5. Okay, so this totals 190 over 5, which gives us a mean age of 38. So the mean age is 38 years. Okay, next we'll talk about the median. The median is the value in the middle of a set of ranked data, okay? That means that it's already in order from least to greatest, and then we find the middle. So let's find the median of the firefighters' ages. So just from the example that we just did, if we put them in order, we rank them first. We have 21, and then we have 30, and then 37, and then 51, and then 51. Okay, those were the ages. I just rewrote them in order from smallest to largest. So we look at what's in the middle. So what I used to do finding these is just scratch off, okay, those ones, and then those ones, and we have the guy in the middle. So we have the median age is 37 years. Okay. Now what happens if we can't do that? So if we have an even number of data. So here I'm going to put these in order first. So we'll have 14, 16, 16, 17, 19, 21, 21, 22. And then from there, I do my same method, so 14 and 22, and then 16 and 21, and 16 and 21. But now I have 2 in the middle. So what I'm going to do is find the middle of them. So 17 plus 19 over 2, right? We find the very, very middle of these numbers. So this gives us 36 over 2, or 18, which makes sense because if I think of what's in between 17 and 19, it's 18. All right, let's do this again. So we'll put these ones in order. They're already in order. That's so great. And we'll just work our way in. Those ones. Okay, 12 and 12. The middle of 12 and 12 is just 12. Okay, if you really want to, you can calculate that, 12 plus 12 over 2, and then we have 24 over 2, and then we get back to 12. Awesome. Okay, the next one we'll look at is the mode, and the mode is the data that happens most frequently. Mode, most. That's how I remember that one. Okay, determine the mode of the firefighter ages. Okay, so the ages were 30, 21, 51, 37, and 51. So if I'm looking at which one happens the most, well, I'm looking at 51. That happened twice, and all the other ones only happened once. So 51 years is the mode. Happens the most. Now, if you have one that maybe there's a number that happens the most and then there's another number that happens the most. So let's say I have like 1, 1, 2, 3, 3, 5, for example. And I can see that 1 happens twice and 3 happens twice and everything else only happens once. Then we would say it has 2 modes. It's bimodal. So the modes are 1, and 3. Okay, you can have more than one mode if they both happen the most. So they both happen twice and everything else happened once. So they're both happening the most. Okay, the next one is called the mid-range. And the mid-range is where we take the lowest value, we add it to the highest value, and we divide by 2. So we're finding the middle of the range, mid-range. So let's find the mid-range of the firefighter ages. Remember, it's 30, 21, 51, 37, and 51. So let's find the lowest. The lowest age is 21, and the highest age is 51. So what we'll do is we'll take 21 plus 51 divided by 2. So we get 72 divided by 2, which gives us 36. So the mid-range is 36 years. And we can kind of see that as we went through each of these different central tendencies, they're all around that 36, 37. Each one of them came around that. Okay, let's look at a different group of data. The salaries of 8 social workers, rounded to the nearest thousand, are 40, 25, 28, 35, 42, 60, 60, and 73. For this set of data, find the mean, median, mode, and mid-range, and then list them from lowest to highest. So why don't you pause, try this out, calculate each one, and then double check it with me, your answer. So first let's find mean. So we're looking at X bar, right? So let's add them all up. We have 40 plus 25 plus 28 plus 35 plus 42 plus 60 plus 60 plus 73. We divide by how many? 8. So we've got 363 over 8. That gives 45.375. All right. I'll move to different colors so we don't get them confused with each other. Next, we'll find median. Okay, so we just need to put them in order from least to greatest before we begin. So we'll have 25, 28, 35, 40, 42, 60, 60, 73. And then I will find the middle. Okay, in between 40 and 42 is 41. Next, we will do the mode. So which one happens the most? Looks like only 60 is happening twice. Everything else only happens once. 60 happens twice. Next, we'll find the mid-range. So we'll take the lowest, add it to the highest, divide it by 2, and that gives us 98 over 2, or 49. And then we will list them in order from least to greatest. So we'll go 41, 45.375, 49, and then 60. which is median, mean, mid-range, then mode. Okay. Now, the last thing I want to talk about is measures of position, and this is how we make comparisons and describe the positions of a piece of data where it falls in the entire set of the data. For example, you may have heard of percentiles before, maybe you've done quartiles before, but in percentiles, they divide the data into 100 equal parts, so there are 99 percentiles, and usually this is when they give a test, so oftentimes the state tests or the SATs, like the college tests, will do percentiles. So if you rank like the 70th percentile, that means you're falling above 70% of the other people that took this exact same test. It doesn't give you what percent you scored, so you didn't get 70% right. You scored higher than 70% of the other test takers. So it's just putting you in position in terms of other test takers. Let's look at one here, the heights of 5-year-olds. Mrs. Judge takes her 5-year-old son to the pediatrician for a checkup. The pediatrician tells Mrs. Judge that her son's height is at the 95th percentile for 5-year-old boys. Explain what this means. Well, if the height is at the 95th percentile, that means that about 95% of the heights are below that height. So we're finding 95th percentile. I'm going to write it. Just means that all of this is 95% of 5-year-old boys. 5-year-old. Their heights fall under here. And then this is the other 5% of heights of 5-year-olds. And this is where her son falls in terms of all the other 5-year-olds. So of all the 5-year-old boy heights that this pediatrician and maybe a few other pediatricians have measured, her son falls higher than 95%, but lower than 5%. So he's measuring a little higher than most boys. So he's tall. Okay, if we look at quartiles specifically, is another measure of positioning data. We'll see them divided into 4 parts. So this first quartile here, Q1, is the value, the Q1 value is higher than 25%. So you can see 25% fits in there. Q2, higher than 50%. So we can see half of the data. And Q3, higher than 3/4 or 75%. And then we have all 100% represented once we get to the end. So quartiles just split up our data into 4 parts. If we want to determine the quartiles, we first list our data from smallest to largest. Then we find the median. The median is that second quartile. If there's an odd number, the median is the middle value. If there's an even, find the median like we did before, right? Halfway between the two middles. Our first quartile, Q1, is the median of the lower half of the data. And then Q3 is the median of the upper half of the data. So you're just finding a whole bunch of medians for each of these quartiles. let's find the quartiles. Here we have Foot Locker, concerned about the high turnover of its sales staff. A survey was done to determine how long the sales staff has been in their current position. And here's 27 responses. We want to determine, oh, it doesn't look like it did my symbols here. We want to determine Q1, Q2, and Q3, all of our quartiles. So first, list it from smallest to largest. So I'm going to take this data and just put it in order. 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20, 21, another 21, 23, 24, 25, 27, 31, 36, 39, and 42. Okay, now that we have it ranked, we can find some medians. So the first one, we just need to find the median of all the data, so you can go through, right, until you get to the middle. The middle is going to be that 17. So let's see if I can get rid of these lines that I've created without messing up all the data. All right, so we have our 17. That is our middle of all the data. That's our Q2, or our second quartile. And then from there, we'll find the lower quartile and the upper quartile. So the lower quartile, or Q1, is just going to be the median of the lower half of the data. Okay, so what we'll do is find the median of the 13 pieces of data that are less than that Q2. Okay, so we'll go through and find the median again, just like we did before. Bunk, 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 all the way down, and figure out that 9 is the median of the lower data. So Q1, or our first quartile, or our lower quartile, all these are synonyms, is 9. And then for our upper quartile, we'll do the same for the higher values. We'll find the median of the values greater than that 17. So we'll go through and we'll find the middle is that 24. So Q3, our third quartile, our upper quartile, however you want to label it, is 24. And the visual representation of all these is coming up, but we usually represent our quartiles in the box and whisker. So if you want to review that on your own, or, oh, I've heard of that, I remember that, I slightly vaguely remember it, this is leading up to that. So finding these values is going somewhere, even though it's not going to be used in this section 12.3. We will get there. Okay, for your homework, make sure you do that biblical worldview. It's due Friday. I know you're going to forget about it, so just take care of it early on. Do it today if you have to, so that way you don't forget. We have covered 12.1, 12.2, and 12.3 this week, so you are still continuing that homework on MyLab, due on Sunday like normal. Make sure you are studying for your final exam. I would look at chapter 3 this weekend, so that way you are reviewing. We already reviewed reasoning. We've already reviewed set theory. So start reviewing logic. Even start reviewing your lines. So putting algebra together and get your brain refreshed on those. As long as you're studying a little bit each day, studying for your final won't feel overwhelming. Email me with any questions and have a great Thanksgiving.